Blackness, not silence, but something deeper. A stillness that feels wrong. Then light. A sunrise begins, but something is off. The horizon glows slowly, too slowly. Shadows stretch unnaturally long, as if time itself is dragging its feet. You raise your hand, you see it, but not instantly. There's a delay, a fraction of a second, but enough to feel unsettling, because something fundamental has changed. Not gravity, not time, not space. But the fastest thing in the universe has just become slower. The speed of light has dropped, and nothing will ever be the same again. The speed of light is not just a number. It is the backbone of reality. In our universe, light travels at approximately 299,792 kilometers per second. It is the ultimate speed limit. Nothing with mass can exceed it. It governs how we see, how we measure time, how cause leads to effect. It defines the structure of physics itself. Now imagine this, without warning, without explanation. The speed of light suddenly drops to half its original value, not gradually, instantly. One moment everything operates under familiar laws. The next, the universe is playing by new rules. What happens next? To understand the consequences, we must understand what the speed of light truly controls. It is not just about light. It is embedded in the very equations that define reality. Einstein's famous equation, E equals mc2, tells us that energy and mass are linked through the square of the speed of light. If the speed of light changes, the relationship between energy and matter changes. Atomic processes change, chemical reactions shift. The forces holding atoms together are affected. Even the structure of spacetime, how time flows and how distances behave, is tied directly to this constant. This is not like changing the speed of a car or the flow of a river. This is like rewriting the rules of existence itself. The change happens instantly. At first, nothing seems different. You are standing, breathing, thinking. But within fractions of a second, the universe begins to react. Light now travels slower, which means information travels slower. You look around, and what you see is no longer perfectly synchronized with reality. Every object you observe is slightly delayed. The world becomes subtly disconnected from itself. But that is just the surface. Deeper changes begin almost immediately. Inside every atom, forces are at work. Electrons orbit nuclei, held in place by electromagnetic forces. These forces depend on constants tied to the speed of light. If light slows down, the strength of these interactions shifts. The size of atoms changes. Electrons may settle into different energy levels. Chemical bonds, once stable, may weaken or strengthen unpredictably. Molecules begin to behave differently. Water may not remain liquid at the same temperature. Oxygen may bind differently with hemoglobin in your blood. The chemistry of life begins to drift, slowly at first, but inevitably. Your body, built on delicate biochemical balances, starts to experience stress. Cells struggle to maintain their functions. Proteins fold incorrectly. Enzymes lose efficiency. Life begins to destabilize. Now consider energy itself. If the speed of light is reduced, then E equals mc2 changes dramatically. The C2 term becomes smaller. This means that the energy equivalent of mass is reduced. Nuclear reactions, like those in the sun, become less energetic. The sun continues to burn, but weaker. Its fusion processes slow down. Less energy is released per reaction. Over time, the sun dims, not instantly, but noticeably. Day by day, the light reaching Earth becomes weaker. The warmth fades. Temperatures begin to drop. A global cooling begins silently. The night sky is a window into the past. Because light takes time to travel, when we look at stars, we see them as they were. Now that travel time doubles. The universe appears older, more distant, more disconnected, but something else happens. The expansion of the universe is governed partly by the speed of light. A slower light speed alters how distances and time interact on cosmic scales. The structure of spacetime begins to shift. Galaxies may appear to move differently. The observable universe shrinks, not physically, but in what we can see and reach. The cosmic horizon pulls closer. Humanity becomes more isolated than ever before. Our world depends on precision. GPS satellites rely on exact timing, governed by the speed of light. Communication systems, from the internet to mobile networks, depend on signals traveling at predictable speeds. Now, everything is off. Signals take longer to arrive. Synchronization breaks. Financial systems glitch. Air traffic control struggles. Satellites drift out of alignment. Navigation becomes unreliable. The global infrastructure begins to fail. Not with explosions, but with confusion. Systems designed for one universe cannot function in another. Einstein's theory of relativity tells us that time and space are linked, and the speed of light is the key. If it changes, time behaves differently. Time dilation, the effect where time slows at high speeds, becomes more pronounced at lower velocities. Suddenly, moving objects experience stronger relativistic effects. Aircraft, satellites, even fast-moving vehicles begin to experience measurable distortions in time. The difference between moving and stationary clocks increases. Time is no longer uniform in the way we expect. The world becomes subtly fragmented in its experience of time. To the human eye, changes are subtle but unsettling. Light takes longer to travel from objects to your eyes. Your perception of reality is delayed. Normally, this delay is so small it is unnoticeable. Now it becomes perceptible. Fast movements appear slightly behind. Reflections lag. Mirrors show you not exactly now, but a moment ago. The world feels disconnected. Your brain struggles to adapt. Reality becomes less immediate, less certain. As the sun's output weakens, Earth begins to cool, seasons shift, winters grow longer, summers grow weaker, ice begins to spread, oceans cool, weather patterns change. Agriculture struggles, food production declines, ecosystems collapse under the pressure of changing conditions. Species that cannot adapt disappear. Human civilization faces a slow, relentless crisis. Not a sudden apocalypse, but a gradual unraveling. In our current understanding of physics, the speed of light is a constant. It does not change. It cannot change without rewriting the laws of physics entirely. This constant is built into every fundamental equation. It is part of the structure of spacetime itself. If it were to change, it would not just be an event. It would be a transformation of the universe at the deepest level. There is no known mechanism, no force, no phenomenon that could cause such a shift, which is precisely why imagining it reveals just how fragile reality truly is. Days pass. The sun dims further. The sky loses its brilliance. The world grows colder. Technology has mostly failed. Humanity adapts slowly, desperately. A new science emerges, a new understanding of this altered universe. But the question remains, is this the final state? Or is the speed of light still changing? Because if it can slow down once, what is stopping it from slowing down again? And if it continues, what happens when light no longer outruns darkness? The speed of light is more than a number. It is a boundary, a rule, a foundation. It shapes reality in ways we rarely think about. But if that foundation shifts, everything above it begins to fall apart. Matter, energy, time, space, all unravel together. This scenario reminds us of something profound. The universe we live in is balanced on constants so precise that even the smallest change could transform everything. And yet, we take it for granted. So the next time you look at the light from the sun, or the stars in the night sky, ask yourself, what if this speed, this ultimate limit, was never truly fixed? And if it could change once, what other constants of the universe are not as constant as they seem?